A very good afternoon to all. In the previous session, so we have completed the unit number 4. Now today we will start with the section 2, and whatever the point is remaining related with the unit 2, so that point we will cover combinedly along with the DSY division, right? So meanwhile we will start with the section 2. So I'm going to conduct some extra sessions. So at that time, so we will discuss the unit number 2. Remaining points we will complete, or will complete all the points which is present in the unit number 2. Right. So now today we will start with the unit number 5. So trees. Right. Now point. So in the tree chapter, we will discuss about the definition, how the tree is traversing, after that linked implementation. And here the different kind of trees are there. So first tree we'll discuss, that is the binary tree, after that binary search tree, and next one is the threaded binary tree. So we'll discuss each and every type of tree here in the these 3 types of trees, and what kind of operations you are able to perform on this tree. So these part we will discuss. Now, what is mean by tree? So can anyone will elaborate the definition? Tree means what?
Dynamic data structure.
Yeah, very nice, very good. It is a dynamic data structure. Again, one more word I am expecting. Good. Tree is a Now, whatever the stack, queue, linked list, binary search, linear search, we discussed. So these are the what type of search? Linear search. Now, tree is a what? Linear or non-linear? Right. Now, here afterwards, so we are going to discuss all these concepts related with the non-linear. So all the tree concept. So in the section 2, I think, is it visible, Tom? So here in the section 2, so tree, multi-way tree, height balance tree, and graph. So tree and graph, right? So these 2 concepts we will discuss in the unit 2, in section 2. All these concepts are related with the non-linear data structure, right? And whatever the concept we discussed in the unit section 1, so all these are the linear data structures, right? Now we will move to the next part, that is the tree. See the tree is one of the non-linear data structure, right? Now in this tree we'll cover the definition, link implementation, operations on binary tree and binary search tree, and introduction to threaded binary tree. Now we'll discuss the definition one by one. So just now first we'll start with the definition. So before proceeding to the definition, so we'll have some prerequisite related with the tree. Now why we need to go for the tree? So already we have a linear data structure. Is it necessary to go to non-linear data structure? What is the purpose? Can anyone will elaborate these things? So we have seen the linear data structure. Is it necessary to study the non-linear data structure? Or what is the actual purpose? Or what is the benefit of performing the non-linear data structure? Now here, left side, this PDF is visible to all. So this PDF, is it visible properly?
Yes, sir. Yes,
Okay.
sir.
Now we'll go through this one, and automatically you will get the answer of the question. Right now, the data structure so far we have seen. So that is linked list, tag, queues. Right now, so most of the time, so these data structure we are using in a what type of applications? So we are using the where we are using the linear data structure. So in such a kind of application only, so we are using the concept of stack queue, right? So if you want to use the linear data, so in that case only you are using the stack queue and linked list, right? Now suppose in many of the application nowadays, in many of the applications, so we are using the non-linear data structure, right? Now we'll take a simple example, everyday's example we'll take. Now suppose if you want to represent the hierarchy of your family, so we'll take an example. If you want to represent the hierarchy of your family, so how you are representing? How hierarchy you are representing? Hierarchy of your family. So here we are considering, we'll say grandfather we are considering, right? Now after that, so grandfather is having two childs, right? We'll say one is our father and another one is our uncle, like this, right? But here, so who is the first element? Now here, now we'll differentiate the difference between the linear and non-linear. Now in the linear, so first element is always connected with the second element. Now first element is connected with how many element? How many next element? Only one element. Now we have seen the so linked list like this. Already we have seen. So this link is connected with only, sorry. So first node always connected with the second node, right? Or is there any situation like this? One node is connected with the two nodes in the linear linked list. Now always in the linear linked list, one node is connected with the next node only, right? Now in non-linear data structure, so this is our first node, right? And this first node is connected with how many child nodes? How many child nodes? One or two? Here in the diagram. So first two child nodes, right? Now, so this is called as a non-linear structure. So that's why we are calling this is the non-linear, because the first child is connected with the, or first node is connected with the next two nodes, right? Now again, so this next node is connected with the few nodes again. So this is first one, again this is second one, right? Again this is third one, like this. So that is depending on the type of trees. That is depending on the what type of trees you are using. So these kind of structure is called as a non-linear data structure.
So then it is hierarchical inheritance.
Hierarchical
Inheritance.
yeah. It is a this is concept of OOPS, right? You are saying the concept of OOPS. Yeah, tree is a hierarchical inheritance. It's part of inheritance only, right? But so this is also inheritance. But here, what type of inheritance you are using? Inheritance म्हणता येत नाही याला, आपण इथं फक्त डेटा टू डेटा कनेक्ट होते, क्लास टू क्लास किंवा मेथड टू मेथड कनेक्ट होतं. This is not a concept of inheritance. Inheritance concept
means that type, sir.
तशा
As
प्रकारे
like that type.
yeah. We'll say like this, but here actually we are not implementing this concept of inheritance. Inheritance म्हणजे काय असतं, एका क्लास मधून दुसऱ्या क्लास मध्ये त्याच्या प्रॉपर्टी इनहेरिट करणे, त्याला आपण इनहेरिटन्स कन्सेप्ट म्हणतो. पण इथं आपण काय करतोय, डेटा टू डेटा कनेक्ट व्हायला लागलो. ठीक आहे, हा त्याच्यासारखा आहे कन्सेप्ट, पण हा डेटा टू डेटा आहे. दिस कन्सेप्ट इज रिलेटेड विथ द स्टोरिंग ऑफ डेटा, म्हणजे स्टोरेज कसं करतो आपण, किंवा लिंकिंग ऑफ द डेटा, म्हणजे डेटा मधलं रिलेशन कसं मेंटेन करतो ते आपण इथे डिस्कस करतोय.
Yes.
Now here, now there are many applications so that make the use of non-linear data structures, so tree, graphs, but our main concern here is tree. Now tree is encountered frequently in our everyday life. Now we have discussed this same example here. Now in linked list, each node has link which points to the another node only. Now in tree structure, so just you can observe here, so each node may point to the several other nodes, so which may then point to the several other nodes, or maybe 1, 2, 3, depending on the type of tree, right? Now there is a flexibility, and again this is the flexible, so there is a not here, it is not a compulsory, so this parent node should be connected with the 2 or 3, like, so here is the flexibility, so parent node can connect with either 1 or either 2 or either 3, so that is depending on the application or depending on the requirement, right? So this is the flexibility here we are providing in this type of tree data structure. And again, it is a powerful data structure, so that can be used for a variety of applications. In so many applications, so this kind of data structure is used. Now suppose we wish to use the data structure to represent a person and all of his or her descendant. Now here we'll assume one. Now assume some person's name is A, and that is that he has 3 children, B, C, D, and also suppose C has a 3 children, E, F, G, and D, right? And sorry, C has 3 children, E, F, G, and D has 1 child, H, right? Now how to represent these tree? Now we can represent A as a and its descendant quite naturally with the tree structures, right? So whatever the descendant we have considered. So how many child nodes are there for the A here? As per this example. So we'll draw the here tree diagram. So A is our main parent. Right. After that, so that A has 3 children. So which one? 3 children. B, C, and D. Right. Now here A is connected with C, D. Right. Now again, C has a 3 children. For a C चे किती children आहेत? 3. E, after that F, and next one is the G. And D is having again one more child, that is H. Right. Now we can represent A and it's a descendant quite natural. Now here you can see. So same. Now trees, so that can be used to represent the data items. So possibly hierarchical relationship between the grandfathers and his descendant in terms their descendant also, right? So we can use only hierarchical. We can't use the inheritance word here. You can use the hierarchical word only, right? Now, so what is the definition of tree now? Now, can I say the first statement? So what is the first statement when you are writing the definition of tree? tree is a what type of data structure? Linear or non-linear?
Non-linear.
Non-linear.
So always you can remember. So if you are writing the definition of stack, so what is the first statement?
It is a linear.
Stack is a linear. Queue is a linear. Linked list is a linear. Right. So these are the few words. Now suppose if you are writing the definition of stack, so you need to remember the word. So it is a linear data structure, and again it uses the one endpoint for inserting and deleting. So these kind of things you need to remember logically, right? So here, in case of tree, so first statement is a tree is a non-linear data structure in which atoms are arranged in a sorted sequence, right? Now it is used to represent what type of relationship? What type of relationship? Hierarchical relationship existing among the several data items. Now here in the tree, so hierarchical relationship is represented with your existing data items, right? Now, or the graph theoretic definition of by considering the graph theory, right? Graph, it is a finite set of one or more data items such that. So in a graph, how this definition is written, there is a special data items called as a root of the tree, and remaining data items are partitioned into the mutually exclusive, that is disjoint sub tree, right? And each of which itself a tree, and they are called as a tree subtree, right? And naturally, tree grows in upward from the ground to ear, right? But tree data structure grows downward from top to the bottom. Now, how these trees increasing from top to bottom or bottom to top?
Top to bottom.
Top to bottom, right? But if you consider the natural tree, so our real tree, so whatever the tree in our real world environment, so that tree is growing from root to child, right? But here, logically, we have considered in a downward direction. So try to understand the concept or meaning of this statement. Now, what is meant by root? So to whom we are calling root here? Now it is a specially designed data items in a tree, right? A is our root here. In the diagram, A is our root node, right? Now it is the first in the hierarchical arrangement of the data. Whatever the first node, when we are arranging the hierarchy, right? So first node we are considering, so that first node is called as a root node. Now in this tree, so A is our root node, right? And remaining nodes are the B, C, D. So these are the intermediate nodes, E, F, G, H. These are the leaf nodes or child nodes, we can say, right? So we'll discuss the terminologies, what kind of terminologies we are using in a trees. So all these terminology we'll discuss. Now root we are calling. Root means this is the root. Now node means, what is meant by node? Node kunal manto. So each data item in a tree is called as a node. So how many nodes are there here in this diagram? So whatever the diagram I have drawn in the paint, how many nodes are there?
8 nodes.
8.
कितने node है? How many nodes are there? 8 nodes. Good. Good. Now, so degree of the node. The number of subtrees of a node in a given tree. So how to calculate the degree of the node? So that part we will discuss. Let me open. So we'll start with the terminologies which we are using in a degree of the node. So what is the definition of degree of node? Now all of you understood the meaning of node. Node kunal म्हणतो आपण?
Each data item.
Each data item. Now, the degree of the node means the number of branches associated with that node is called as the degree of the node, right? So whatever the node or whatever the node you are considering, right? So to that node, so whatever the branches means here, so A is there, right? Now how many branches are there for the A? किती branch आहे त्याला?
3 branches.
3 branches are there, right? Now this is called as a degree of the node. This is called as a degree of the node. Now we'll take one simple example. Let me draw one example so that now suppose here you have A, right? After that, B. Now here I will use the arrow. Here is the C. Should not move fast. D. Here is the E, A, B, C, D, E. Next, we consider F. Here, G, H. तिकडे लॅब मध्ये Now how many nodes are there here? Is it visible to all?
9 nodes.
9.
9.
9 nodes.
A, B, C,
9.
D, E, F, G, H, I. Right. Now, so what is the definition of degree of node? The number of nodes associated or number of branches associated with the node is called as a degree of the node. Now, degree of the node we are calculating by considering the degree of node is equal to in degree plus out degree. In degree plus out degree. So what do you mean by in degree? In degree means, so this is the B node, right? Now how many branches are coming to B? या B ला येणारे किती नोड आहे? येणारे branches?
1.
1. And
1.
how many are going out from the B?
2.
So what is the in degree of B here? When the in degree किती झाली 1 झाली and out degree किती झाली ह्याच्या B ची? What is the out degree?
2.
2. So here, so can I say like this? So in degree of node means, so the branch is directed towards the node is called as a in degree of the node, and out degree means, so branch is directed away from the node is called as a out degree of the node, right? So in degree means, so directed towards that node is called as in degree, and if directed away from the node is called as a out degree of that node. Now we'll consider the node. Now what is the degree of node A? What is the degree of node A?
Out degree 3.
Out degree 3. And what is the in degree?
0.
0. Now no need to write here. Okay, good. Now what is the degree of B?
Out degree 2. In degree 1.
Total.
3.
Right. Now what is the degree of C?
In degree 1. Out degree 0. Total 1.
All of you have got the concept. What is mean by degree?
Yes,
Degree,
sir.
degree concept लक्षात आला? Now,
Yes, sir.
Yes.
now whose in degree is always 0?
A.
Hmm?
A.
Root A.
Root.
What is the answer?
Root.
Whose in degree is always 0 or compulsory 0?
Root degree.
Root node. So what is the answer? Root node. MCQ ला हा क्वेश्चन विचारला जाऊ शकतो. If a tree is not empty, then first node is called as a root node, and the in degree of the root node is always 0, excluding root. All of the node must have in degree exactly 1, right? Except root node, or excluding root node, all of the remaining node must have the in degree exactly 1. And again, so what about out degree? Now all the nodes in your tree can have out degree of 0, 1 or more than 1, right? So there is no any compulsion for the out degree. Maybe it will be 0, or maybe it will be 1, or maybe it will be more than 1. Now here, the thing you need to remember, that is the always the in degree for the root node is 0, and except root node, so all the remaining nodes have at least 1 in degree, right? So these things you need to remember. And regarding out degree, so it maybe it will be 0, 1 or more than 1, right? So all of you have understood the concept of degree of the node. This is the basic concept. So we are discussing the few basic terminologies before moving to the our concept of tree. Now we'll discuss the next concept. What is meant by leaf node? Leaf node. Or you can dictate it in your notebook. Right. Now a leaf node is any node, so whose out degree is 0. To whom we are calling leaf node? Leaf node कोणाला म्हणतो? Whose out degree is 0. So such node is called as a leaf node. Now here, tell me the name of leaf nodes.
CD. Node C, node D, node G.
G. C, D, G, H, I.
C, D, E, G, H, I. So these are the leaf nodes, right? Now next is the internal node. Internal nodes. Now I will explain that first. Now here the internal node is not your root node, and internal node is not your leaf node, right? A node that is not root or not leaf is called as a internal. Internal node कोणाला म्हणतो आपण? So if the node who is not a root node and not a leaf node, so such node is called as an internal node. Now here, how many internal nodes are there?
2.
Three, sir. Three nodes.
Which one?
B, E, F.
E and F.
Internal node आहे का? E.
No.
No, sir. B
B
and F.
How many are there here? Internal
Two.
nodes? Only two.
Two.
Right. Now next, parent node. Next one is the parent node. Now, what is the definition of parent node? The node who is having the successor nodes. The successor node astil, or is there any child is there? So these node is belonging to the parent node. So here, how many parent nodes are there?
3.
3. Which one?
A, B, F.
A, B. Yeah, good, good. Now child node. Next. A node with a predecessor is called as a child node, and it has in degree at least 1. So tell me the child node now.
8. B, C, D, E, F, G, H, I.
B, C, D, E, F, G, H, I. All these are the child nodes. So because all these node is having the predecessors and their in degree is 1. Right now the next child node we discussed. Next, sibling. Sibling node, or we'll say siblings. So to whom you are calling siblings? Siblings कोणाला म्हणतो?
The node having same parent node.
Okay, good. The nodes having same parents are called as a siblings. Now here, so you can consider B, E, F are the siblings. Siblings means brother, sister, like this. Siblings. So here, those who are having their same parents, right? So can you tell me, so how many sibling nodes are there here? Or how many siblings are there? किती siblings आहेत तिथं?
Three.
3 आहे. Roll number B45. Aditya.
Yes, sir.
So I know what you are asking.
Sir, आता जे तुम्ही लिप नोड इंटरनल नोड लिहिलं ना त्याच्या पुढे सर एक्झाम्पल लिहा लाईक बी नोड बी नोड डी असं.
Yeah, here you are expecting.
Yes, sir.
What should I write? Leap node. Leap node काय लिहायची मग इथं? C, D, E,
G H I.
E, H, and I. So like you are expecting like this, right? Internal node B,
D, F.
B, F. Parent node B, A.
A, B.
Child node
B, C, D, E, F, G, H,
B,
I.
C, B, C, D. Now you are understood. Now here,
Yes, sir. Also write sir root node.
where is the root node? Root node we have not written here. Okay. Now, or otherwise you can dictate it in your notebook also, right? So when I'm explaining, so you can dictate it in your notebook, and this will be for your reference. Now sometimes, so I'm explaining, but I'm not writing on a notepad or in a notepad for few of the things. So due to writing, so we are taking here, we required more time. So that's why I'm skipping the writing part, right? So in that case, so you can dictate it in your notebook. Now siblings. So how many siblings are there here? So first is the BEF, and second one is the CD, and third one is the
GHI.
GHI. Got it?
Yes, sir.
Next concept. What do you mean by age? EDG. Age. Age को नाम होता है a line drawn from one node to another node is called as a age. Age means a line drawn from the one node to the another node. So this arrow is called as age, right? Now next, then what is mean by path? What is mean by path? Path ko naam mila. What is the definition of path?
Way.
The sequence of nodes in which each node is adjacent to the next node. Now here, from A to C, so this is the path, A, B, C. Now A to D, so A, B, C, D, A, B, D. Suppose if you want to traverse to the H, so how you are traversing? A, F, H. So this is called as a path, right? And age means, so this is the single line we are considering as an age. And path means, so it's combination of source to destination. So whatever the edges we are required, combination of edges is called as a path, right? Or we can say sequence of nodes in which each node is adjacent to the next, right? So this is called as a path. And next is the level of nodes. Now all of you, if you required, so you can dictate it, or I will share the notes, don't worry about that. In that notes, all these definitions are available. So level of nodes. Level of nodes.
Sir, repeat path once again. Path.
Path means, suppose if you want to travel from A to H, so how you are traveling?
A to F and then F to H.
This is called as path.
Yes, sir, got it.
Now level of nodes. Now next is the level of node. So this is the distance from its root node. Now what is the level of A? Now in that case, level of node means it is the distance from the root node. So what is the level of A in that case? Can I say 0? Because A is already a root node, and if you are calculating level of node A is, it will become 0. Now what is the level of B?
1.
Good. Now what is the level of E? Each level cache?
1.
1. Right? Means distance. A level of node means it is a distance from the root node, right? Now we'll take C. What is the level of C?
2.
2.
What will be the highest level here in this diagram? Highest level
Two.
2 is considered.
2.
2,
Now what is the level of F?
1,
1,
1,
2,
2.
H, I,
2.
2,
right? So level of nodes. Next, height of the tree. Height of. So what is the height of the tree? Tree ची height किती आहे?
3.
3.
3,
So how you have calculated 3? You have considered the number of levels, right? So first A for the first, this is the second, and this is the third, right? So in this way, we are calculating the height of the tree. Now one more concept we are using, that is the subtree. What do you mean by subtree? Can I say this is the subtree of A?
yes,
Yes.
Yes. So this F is also, suppose if you consider F as a root, and this tree is connected with this tree, right? So this is the subtree, right? Subtree means the tree may be divided into subtrees, or subtrees connected structure below to the root node of the other. So these are the few terminologies we are using in the tree concept. Now all of you understood. Is there any doubt up to this? Few terminologies we have discussed here. Is it visible to all?
Yes, sir.
Now we'll see the next concept, that is the binary tree. What do you mean by binary tree? So binary tree is a special type of tree, so which consists of either no childrens. So all of you give attention here. So this statement is very, very important in case of binary tree. Now binary tree is a special type of tree. Now we have started the first point, or first type of tree, that is the binary tree. Now we have discussed the definitions and representations and everything, right? Now the first tree is binary tree. So first we'll discuss the binary tree, and for that binary tree, so how many operations you are performing and everything we will discuss. After that we'll discuss the binary search tree, and after that threaded binary trees. Now here the binary tree is a special type of tree, so which consists of either no childrens, or one children, or two children, not more than two children. Now here I will draw. Now here, so this F is having how many children?
3,
3.
Or A is having how many children? 3. A ला किती children आहे?
3,
3, right? Now for the B, how many children are there?
2,
Right. Now suppose you have two trees, right? So one is having the root node B and another is having root node F. Just you can consider. Now to whom you are calling binary tree? To B or to F? Binary tree कोणाला म्हणणार यामध्ये?
B.
This is called as a binary tree. And this is not coming under the binary. Why? What is the reason?
Child root B ला 2 आहेत आणि F ला 3 आहेत.
Yes. Now, the binary tree is a partial type of tree, so which consists of either no children, one children, or two children. If more than two children means, so these kind of tree is not belonging to the binary tree. Binary tree la maximum. For the binary tree, how many maximum children are there? Only two. Now, binary tree is very important and most common used non-linear data structure with the maximum degree of any nodes is at most 2. So maximum degree of means here maximum out degree of the binary tree is 2 only, not more than 2. Out degree is only 2, not more than 2. You can consider out degree 0, 1 or 2, up to 2. Now the child of the node is in the binary tree on the left is called as a left child, and the node which is present on the right side is called as a right child. Now here the example is given. So this is called as a binary tree. So can we say this is the binary tree? Binary tree आहे. Now A is having how many childs?
2.
B,
1.
C,
2.
E, not 3. 3 कसे आले?
Yes, sir.
Directly किती childs आहेत? Directly किती? Only 2, E and F. And E is having another child. E is having their own child. That is G. Right? So for C only 2. Now suppose here one more child is there. इथं आणखी एक असेल. H असेल. So at that time, so can we say this is the binary tree? एक जरी इथे चाइल्ड आला तर याला बायनरी ट्री म्हणू शकतो का आपण?
No.
Right? So but here, so we are considering the in this case, so we are considering the child node either 0 or either 1 or 2. So all these three conditions you are considering here for these three, right? Now next is the strictly binary tree. Next concept is the strictly binary tree. Now if every non-terminal nodes in a binary tree consist of non-empty left subtree and right subtree, then such tree is called as a strictly binary tree. So example of the strict binary tree. त्याचे left आणि right child कुठल्याचेही empty नाही. So here, so this is the root node, right? Now this root is having how many childs? 2, right? And B is having how many childs?
2.
And E is having how many childs?
2.
Right? So either 0 or either 2. So in the strict or in strictly binary tree, how many childs is required? Either 0 or either 2. Not one child is not allowed in case of strictly binary tree. Right? Now here, a strict binary tree with n leaves always consists of 2n minus 1 nodes in the binary. Now next is the complete binary tree. Now in case of complete binary tree is fully binary tree in which all the leaves are at the same level. So whatever the leaf nodes you are considering, so all these leaf nodes should be at the same level only. जे leaf node असणार आहे सगळे कुठल्या लेवलला पाहिजे at the same level. So these kind of tree is called as a complete binary. Now how to calculate the node of the complete binary tree? The total number of nodes in the complete binary tree is calculated by using the 2 raised to h plus 1 minus 1. Now what is the value of h here? What is the value of pH?
Three.
Right.
Two.
So 1, 2, right? So 2 raised to 2 plus 1. So 2 raised to 3. So what is the value? 4 into 2, 8. 8 minus 1 means 7. So 7 elements are there, or 7 node is there. Yes, is it? So in this way, we are calculating the values of complete binary. Now, how many types of binary tree we have discussed? One is our simple binary tree, right? After that, strictly binary tree, and next one is the complete binary tree. Now, what is the difference between the complete binary tree and strictly binary tree? या दोन्ही मधला काय difference आहे? Difference between the strictly binary tree and next one is the complete binary tree. What is the difference? Yes. या दोन्ही मधला difference काय आहे? Strict binary tree and complete binary tree. Hello. Am I audible to all? In the strict binary tree, so how many child nodes you are considering?
0 or 2.
0 or 2.
Dot
Now, in case of complete binary tree, how many child nodes you are considering?
2.
You are allowing 0, 1.
No.
This is the first difference. This is the basic difference. And so all the leaf nodes are present at which level? In the complete binary tree. Leaf node कोणत्या level ला आहेत सगळे?
Same level.
At the same level. But in strictly binary tree, so all the leaf nodes are at same level. आहेत का same level ला?
No.
No. So this is the second difference, right? And third type of the binary tree is the scaled binary tree. Scaled means if a tree contain only left or right branches, such tree is known as a scaled tree. Now, if the tree is contain only left branches, so this is called as a left scale. And if the tree is containing only right branches, so this is called as a right scale. Left scale is one which has only left scale branches, and right scale is one which has only right branches. Now, up to this, is there any doubt or is there any questions? Now we'll discuss again very interesting. Next is the expression tree. Now we know the expressions, right? So when any expressions containing operand and operators, so shown with the help of binary tree. So these kind of tree is called as a expression tree. Right now here, next is the expression tree. So this is the equation A into B plus. Now here, so what is the sequence of operation? Now don't go to the tree. Now how you are performing the operation? Which operation you are performing first? Here.
A into B.
A into B you are performing separately. Or are you first combining B plus C?
No, sir.
Right. So here A and B is separately written. Right. Now after their result, so after combining the result of this A into B, so So you are performing addition with whom?
Hmm.
Right. So here, so the same concept is used. The same concept is used. Now here, who is the root in that case? May the root कौन असेल? Root कुठला operator?
Addition.
Yes, addition. And left side la, at left side, so star will be the left child of the plus, and at the right, C is the another child. Now, the here multiplication is having two childs. One is A as a left child and B as a right child, right? So in this way, so when the binary expression containing operands and operator shown with the help of binary tree is called as a expression. Now sequential representation of a binary tree. So how to represent by using the sequence or by using the number? So that is given here. Now the part is related with the representation of the binary tree. So we have discussed about the binary tree. Now all of you got the concept regarding the binary tree. Now we'll see how to represent the binary tree by using the linked list concept. Now in the binary tree, so what we have discussed, so how many types of tree we have discussed? कोणत्या टाइपचे ट्री बघितलेले आहेत? So simple binary tree. After that, next one is the strictly binary tree,
Complete binary.
complete binary tree. Next one is the
Skewed binary tree.
skewed binary tree, and after that, expression tree, right? So this is also very interesting. Expression binary tree. Now we'll see the now the sequential representation of the binary tree. So what is this? So each node is sequentially arranged from left to right and from top to the bottom. Now, how these nodes are arranged from top to bottom and from left to right. Now let's understand this by numbering each node. So numbering will start from the root node and then remaining nodes will give the interesting number in the level wise direction. The nodes in the same level will be numbered from left to right. Right. So here 0, 1 at one level, 2, 3. Right. So forget about this. So this is not a part of. Now, next very important part is the representation of the binary array. Now, how to represent the array by using the linked list? Now, to represent a single node of any array in a binary array, so how many fields you require? Fields किती लागतील? How many fields you require? To represent a single node. To represent a single node. So first is the data of that node, right? Now after that, how many childs you are considering to the one node? How many child you are considering for one node in binary tree?
2.
only 2, right? So here the one field we required for the data and one field we required for representing the left child relationship, and third field we required for the right child relationship. So here, so how to connect with the other node? Other node ला आपण कसं connect होतो?
Link.
Link, right? So link is a variable or pointer? What type of variable? It is a pointer variable.
Pointer.
Yes.
Pointer.
So here I will write the C structure of the node in the binary tree is struct node. So char data. So right. So you can consider character or integer. Right. So here we have considered char data struct node. So child. So here one child we have considered, and struct node child D we have considered. Means here 2 pointers we have considered. One is for the left and another one is for the right. Now, if you are having a single node, if you are having only a single node and who is having the value 10, so what will be the value of data in that case? तुमच्याकडे एकच नोड आहे आणि त्याची व्हॅल्यू आहे 10. So what is the value of data? डेटाची व्हॅल्यू किती असेल डेटा फील्डची?
10.
10. Now what is the value of left pointer?
Address of 20.
एकच नोड आहे तुमच्याकडे.
null.
Null.
Good. And address of the right point, value of the right pointer,
Null.
Null.
right? Now suppose you have 2 nodes or 2 values 10 and 20. So 20 is at left side of the 10. Then what is the value of left pointer of 10?
Address of 20.
Address of 20. Now what is the left pointer value of 20?
Null.
Null. And what is the right pointer of 20?
Null.
Null.
And what is the right pointer of 10?
Null. Null.
Now, are you comfortable with the linked list? Now, suppose I have given this example. Now, draw the structure of a linked list. Is it possible for you?
Yes, sir.
Linked representation of a binary tree. So, I will say this is the linked representation of the binary tree, right? Now, here 10, 20, 30, and 40, 50 is given. Now, what is the value of 10? So, how to represent? So 10. So what is the left pointer value here?
20. Address of 20.
Address of 20, right? Now here come to 20. So what is the left pointer of 20?
Address of 40.
Address of 40.
What is the left pointer of 40?
Null.
Null.
Right pointer of 40.
Null.
Null.
Right pointer of 20.
Address of 50.
Left pointer of 50.
Null.
Null.
Right pointer of 50.
Null.
Null.
Right? And right pointer of 10.
Address of 30.
Of 30.
And left pointer of 30.
Null.
Null.
Right
Null.
pointer of 30.
Null.
Good. Now all of you have understood. So today we have discussed about the concept of binary tree, right? And different types of binary tree also we have discussed. Now we are discussing the how to represent the binary tree by using the linked list, right? Now, is it possible to connect one node with the multiple nodes by using the binary tree? आता हे programmatically करता येईल का? Is there any difficulty here? So what is the main logic when we are connecting with the multiple nodes? So you need to consider this references left and right. So whose address you are storing? So that is very important, right? Now if you are storing the address of 20, so 20 is connected at the left side of this node, and for the right, so if you are storing the address of 30 means it is connected with the 30, right? Now again 30 will connect with the next two. Now 20 will connect with the next two likewise. So this binary tree will grow. or will start growing from top to bottom or bottom to top?
Top to bottom.
Top to bottom. Now here, so to perform the insertion and deletions are more easily uttered than the sequential structure. Now here, these are the basic operations performed on the tree. The basic operations to be performed on the binary tree are the first, we need to create an empty binary tree, right? After that, make the binary, it creates a new binary tree having a single node with the data field and set to some values, right? And if it is empty binary tree, it returns the true if the binary tree is empty, otherwise it returns the false. Now left child, right child, father, brother, and data. So left child means, so it returns the pointer to the left child of the node. If the node has a node left child, it returns the null pointer. If right child means R child, it returns the pointer to the right child of the node. If the node has no right child, it returns the null pointer. So father means it returns the pointer to the father of the node, otherwise the null pointer, right? So this will be considered as a root. Brothers means sibling nodes. So it returns the pointer to the brother of nodes. So otherwise null pointer. And data means return the content of the respective nodes. So these are the operations we will discuss in detail. Now, is it visible at all? Is it visible? So this PDF.
Yes, sir. Yes, sir.
Okay, good. Now, next again, very interesting and very important part, that is the traversing. So how to traversing of the binary tree, right? So pre-order traverser, in-order traversers, and post-order traverser. So these three types of traversers are there, right? So these we will discuss in detail, right? Now up to this, so is there any doubt? So whatever the part we have discussed today, up to representation of a binary tree. So today we discussed the definition, representation. After that, so we discussed about the meaning of the binary tree and whatever the terminologies be required for the tree concept. So required terminologies we have discussed, or definition of all the terminologies we have discussed. Right. Now again, the next part is the very interesting. So that is the traversal of binary tree. Now any questions up to this you can ask. All of you understood? So whatever the point we have discussed.
Yes, sir. Understood.
Good. So if you have understood, so you can write yes in the chat box. If you have not understood, so you can unmute yourself and ask the question. So here 99 student is attending the session. So why other so many students are absent? I think what is the total strength? 138. 38 students were absent. 39. Okay, if you are having any questions, so you can ask. Now next point, that is the traversal of binary tree. So pre-order traversal, in-order traversal, and post-order traversal. This part we will cover in the next session, right? Now after that, so again we have to perform the in-order, pre-order, and post-order traversals, right? By considering the examples of the, and after that we'll see the binary search tree or BST, how the BST is working. So that part we will discuss. And last point of the unit 4 is the binary threaded binary tree, right? Threaded binary tree. So this part we will discuss later. So today we have discussed the binary tree. Till the few of the part is remaining, there is a traversal of binary tree. That part we will cover in the next session. Now we'll take a pause here. So if you are having any questions, so you can ask. Otherwise, so you can drop. Thank you.
Sir, send notes of chapter on group.
I will upload it on the teaching diary so that it will be better for you. So what is the problem? So if I upload it on or if I submit it on group, so after few days, so automatically it gets deleted from my side, or at that time you are not able to download. So what I am doing, so once your unit is completed, so all the notes related things I am uploading on a teaching diary. So you can refer the teaching diary for downloading the notes. Already I have added one more column in there. So notes of the respective units. So up to list, already I have uploaded the things on teaching diary. Up to linked list. So I have uploaded all the notes, right? Now, if you wish to share on a group, so I will share it on a group, but better way. At any
No,
time,
better, it's better on teaching diary.
yeah, it will be accessible to all at any time, right? Sometimes
Yes, sir.
on a WhatsApp. So what I am doing, I am deleting some backups. So after few days, or automatically backup is get deleted after 30 days. So at that time, now you can check. So before, I think previous 2 months, or if I shared any document, so now you are not able to download it.